This is a look at some of the features of Rippletank. First of all, the kind of thing that you might do with a normal Rippletank. With the real thing, it can take a while for the ripples to settle down, and it can be quite confusing. With a simulation, you can just press the reset button and everything's cleared, ready to start afresh. There are a range of tools you can use to visualize what's going on and make measurements. This one's visualizing the height of the ripples across a cross section, and it's showing how you can investigate standing waves. Refraction is one of the things that you might want to investigate with a Rippletank. This is looking at waves entering a more dense medium. We've got a protractor, and we're going to use the guides to set that up as the normal and then measure the angle of the wavefronts. The pause button can make this a lot easier. And with the simulation, you can change refractive index just by moving the slider. Again, pausing and using the wave guides makes this really easy. Next, let's have a look at waves leaving a dense medium. This is quite an obtuse angle, so let's see what happens. As you would expect, we've got total internal reflection. Students could use this to investigate critical angles. This is showing curved mirrors. The little grey dot shows the focal point. The beam is focused and passes through the focal point. And you can see what happens when you adjust the focal point. You can also send a pulse of waves. This can make it a bit easier to see what's going on. You can also investigate lenses. You can adjust the focal length of the lens and see what happens to the ray. The Doppler effect is also a really interesting thing to investigate. The wave source follows the little green handle. There's also a handy little button for positioning everything to do Doppler effect investigations. The spectrometer is really useful for measuring frequencies. With the Doppler source, you can also set up a complex waveform to help simulate redshift. You can see the waveforms appear on the spectrometers. It's a series of lines. This can show redshift and blue shift and gives an idea of how the patterns are recognized within a spectrum. The spectrometer's got several settings for showing graphs or just the colours, and for faster or more accurate measurements, and for linear by frequency or by wavelength. You can also investigate what happens with slits. The intensity tool shows a representation of what it might look like with the laser light shining through the slits, for example with the Young's double slit experiment. You can change the number of slits and the gaps and so on. You can also show what happens when you change the wavelength of the light. This is showing how a fibre optic cable uses total internal reflection to guide the waveform along it. You can investigate the fibre optic cable by changing the amount of curvature, adjusting the width of the cable, or changing its refractive index. This simulation is showing how waves travel through the atmosphere. The first model shows how waves reflect off the edge of the atmosphere. The second model is non-linear and shows how the waves can be refracted around the Earth. Earthquakes in the structure of the Earth can also be investigated. This is showing how paper tape loggers can be used to measure the strength of the earthquake and the time it takes to get to different parts of the Earth. On the left hand side, you can see the measurements being made. When you're happy, you can pause it and then you can slide the tape back and find the time of whatever event you're interested in. You can do a similar thing with tsunamis. You can investigate whether certain areas are more sheltered or more exposed than others. This is a demonstration of just some of the features. If you'd like to know more, please go to rippletank.co.uk. There's also a free demo you can download to get an idea of how the simulation works. Thank you and goodbye.